Hi everyone, this is Peter Diamandis right here, Diamandis I should say, and should we pay attention to him? I think we should. He is now considered one of the top leaders, top 50 leaders in the world according to Fortune magazine. I don't know who the other top leaders are, but he is in that number 50, and he is really into space, and he's started all of these things with X, and don't you wonder about the X in the sky that we see all the time? Anyway, he started the X Prize. He started um, well, the X Prize is people, they're trying to get into space and get the human race off of Earth to kind of pioneer and conquer space and move off the planet now that we've destroyed it, probably. But he's really a brilliant person, godless though. And I just want to show you one of his plans that he started almost 2 years ago. That was in 2013, February 2013, predicting that within 2 years there would be swarms of miniature spaceships that go out and capture, harness, and claim asteroids. And remember, the Rosetta, it landed on an asteroid, didn't it? Okay, I might get my facts a bit mixed up, but why were they so interested in asteroids? Well, it turns out that asteroids have a huge amount of rare earth metals, because that's where all the metals came from that are on Earth, the platinum group metals. So they are going after that. They want to claim it. They want to like put a flag on it and claim it before anyone else does. So he see the X Prize, and what are all those X's that are in the sky all the time, and what does he have to do with it? I don't know. He's part of Google, NASA, Genentech, Cisco, all these, extreme technologies that are moving exponentially, and he's very much an advocate of disruptive technologies that just take over and replace the old. Anyway, look at the title of this YouTube video. So this was in March. We are evolving into meta intelligence group minds. Well, I guess we are, because we're on the internet all the time. And we can't really help it. And seems to me that the computer is reading our minds these days. Have you noticed? I have. I would like to show you something that happened to me just day before yesterday or so, but I have to track it down. And it was a really weird thing, because I don't know how to bold any words here, but I was thinking I wanted to bold something, and the next time I looked at the comment, it was on a comment, the exact thing that I wanted to bold was bold. How can that be? I don't know. It's kind of a mystery. I'll try to track it down. What is they saying right here? Kindness and happiness are not growing by outer technologies. These human quality only evolve with practice, a moment by moment practice, where one learns how to care for others independent of any realm of existence. Yes, that's true. Technology is going to make people kinder and happier, I don't think. But anyway, this is not the one that I want to show you, but you can look up all of his lectures. Some are repetitive because he has a script down that he talks about. I've watched quite a few of his presentations, and they all revolve around pretty much the same thing, except, okay, I'm going to get rid of that, except this one here is really quite fantastic, and that is Google Solve for X 2013. So I'm going to click on it. Oh, I wonder what this is. Google Zeitgeist Americas. Google Zeitgeist. Google Spirit. Ooh. Google kind of freaks me out, you know. So, if you watch Star Trek, then you probably know what this name comes from. I was never a Star Trek fan, so they explained it in here what this means, but I'm just going to click on a few points, you know, randomly, because I didn't, you can watch this also on YouTube, but solve for X.
So the talk here on planetary resources is entitled Harvesting Asteroids to Fuel Human Exploration and Prosperity.
Okay, harvesting asteroids. So they want to harvest asteroids, and in this talk he goes on and on about what they're worth in monetary value. So, but okay, I'll click on some random places. Then I suggest that you go and watch it yourself. I'll put the link down. So I'll put the link to his blog so you can go check out all of these and see which ones you want to watch. But I suggest this one because, okay, let's see if I can find. Okay, I'll just go random because I'm not really sure how else to do that.
Incredible. The other class of asteroids, the second of the three I'm interested in, is LL chondrites. These are asteroids that are rich in platinum group metals.
Platinum group metals, you know, rare earths, and also they're rare on Earth, but if they suddenly capture all these asteroids that have rich in platinum group metals, won't that cause the price of platinum to go down?
Literally, you know, rubidium and palladium, osmium, iridium, platinum. And the numbers here are themselves amazing. One 500-meter LL chondrite nickel iron asteroid has more platinum than has ever been mined in the history of humanity. And we have 2,500 of these in the 500 class that come near the Earth. So why are these of interest to us from a mining standpoint? Well, as it turns out, the Earth, when it was formed, all of the iron-loving, the siderophile metals, the PGMs, literally sank to the center of the Earth. And they sank there because of differential gravitational settling. But little...
Okay, I'm moving on because we don't want this. Okay,
of,
see this right here? This is the new spaceship that they have developed. Spaceship that goes into space, and it starts to orbit an asteroid. I don't know how they orbit an asteroid because supposedly an asteroid doesn't have gravity, but he compares this spaceship to the old spaceships from before, that how much they cost and how everything is being condensed and reduced and everything's getting cheaper and smaller, and how these are going to be swarms in the sky. And if this was in 2013 February, then it would be 2015 when they're doing this. Okay, let's see. Okay, then he introduces his friend Eric Anderson, his partner, and they really sound like greedy corporate mongers, but they speak in general terms like we're all going to benefit. But of course, we know we aren't, because they want to X everyone out, right? You know, Georgia Guidestones, etc. Okay, let's see what Eric says here. We've got a little...
Be dependent on government. This cannot be subject to the vagaries of NASA or the Congress's wishes on what they'd like to spend money on, so certainly not for funding, but also not for infrastructure. We cannot depend on NASA. We cannot depend on the Deep Space Network, and so we are going to have to build a system that can stand on its own two legs commercially, from an infrastructure point of view, from a technology point of view. Number two, we need to be able to produce spacecraft every year numbering in the hundreds, okay, eventually thousands, not one per year. Today, and for the past couple of decades, certainly, building a rocket or a spacecraft has been like creating a piece of art. It has been something that is the furthest from mass production that I can think of, okay, and we need to take that and just flip it over, completely over. Number three, we need to create systems that are as close to possible, or as close as possible in cost, in terms of going out and prospecting and gathering data as is doable, commensurate with what the mining industry and the resource industry is used to today.
So they want to do hundreds of these spacecraft per year. Just can you imagine, with all of these satellites and spacecraft and drones and, you know, lasers and everything that is up in the sky. This is really what they want to do, and they are prospecting and they want to mine. So let me go to something else here when he actually unveils this. Okay, now this thing right here is one of the original state-of-the-art 1997, cost 800 million, weight 4,300 pounds, resolution 15 meters. So this is how small it's gone. And notice here, this is all gold foil. They use gold foil in space. So that's one use of gold that a lot of people don't think about. NASA uses a lot of gold on their spaceships, and sometimes they burn up. They don't get that back.
For that $800 million, you got 15-meter resolution. That's 15 meter basically per pixel. Okay? Not bad for 1997, but I mean, literally 2 or 3 orders of magnitude worse in cost performance than we're going to show you today. Okay, what was the state of the art just 5 years ago? This is a commercial project. This was financed commercially, so we can't even attribute part of the inefficiency to the government work there. This was financed commercially. A project called Rapid Eye, 2007, $40 million cost for a satellite. It was able to be
Can we move it up here to
the 2 spacecraft I showed before, actually Earth observation spacecraft.
The unveiling.
And even though this guy is intended to analyze asteroids and will do a really good job at it, we're getting a lot of interest from Earth observation customers. You know, for $4 million, you could launch a constellation of 5 or 10 of these if you're a company, you know, a mining company on Earth, for example, and really have an incredible ability to survey and gather intelligence on land today for what would cost billions of dollars.
So survey and gather intelligence on land, of the land and of the people. And remember, these are going to be high-powered focus, lasers, cameras, everything. And the time is now, 2015, where they want to launch hundreds of these into space. So you know what I mean? When you look up into the sky in the clouds and you see all those little white things that look like orbs or whatever, they could be this kind of a thing that's up there that ends up looking round, and they're swarming around the chemtrails, etc. That's just my opinion. So anyway, I'm going to leave this in a minute because I'm already at 13 minutes and made too many long videos. I'll just go here and see what he has to say towards the end.
Because it was too risky. So in terms of spacecraft diagnostics, going to an asteroid and sending us back the 3D file of, send us the file that is the asteroid. What is the spin rate? What is the debris cloud? What is the albedo? What is the characterization of the materials on it? All of those things coming back as the actual answer. And the third is just to build them in a swarm. The concept of distributed computing, that is what we do. Distributed spacecraft. There's lots of reasons for that. I won't go into it right now. I can certainly talk to you about it later, but it makes perfect sense. You take so much risk out of the system when you don't spend the last, the 50% of the cost going in to try to reduce the last 2% of risk of a spacecraft. You don't need to reduce the last 2% of risk if you take 7 of them, because you can afford to lose 1 or 2 and you still have perfect mission success. Anyway, this is an Arcad 100 and its mission. So the first mission for the Arcad 100 is to go to orbit and take the list of top 20 or 30 asteroids that we are most interested in right now. So as Peter mentioned, there's actually about 10,000 near-Earth asteroids that have been discovered. That pales in comparison to the millions in the asteroid belt, but there are 10,000 that have been discovered already. And we've got our little hot list of 20 or 30. But
okay, so that they want to put swarm little mini spaceships out there, hundreds. Who knows what they're going to do? Processing a metal-rich asteroid.